Hey there. So let's start with a Singleton design pattern. Uh, we'll look into what are the uses of Singleton design pattern and how to create Singleton design pattern. So here first, what is Singleton design pattern? As you can see on the screen, that is the Singleton pattern is a software design pattern that restricts the instantiation of a class to one single instance. What does it mean? It's like if you try to create multiple objects of a class which have implemented the singleton pattern, and every time when you try to retrieve that object, it will return the same instance and same object every time. For any number of times you try to uh, create an object or to get an object, you will get the same object. The same object, I mean to say that there will be only one object created which is getting returned every time we are calling that object. So the best example for singleton pattern is this task manager. I will show you as how task manager uh, is implementing this singleton design pattern. So here we are on a desktop screen, as you can see, home screen. So I will try to create a task manager. Open a task manager. So here you can see I have one pop-up of task manager. Let me try to open one more task manager pop-up. Okay. Okay, let me try once again. So here you can see that I am calling this task manager multiple times, but here what I have is only one instance of it, or only one pop-up window of task manager. So this is a good example of a singleton design pattern. As you can see, I'm trying to get multiple objects, but I only have the one object or the same object every time. So yeah, now let me try the same with the folder. Okay, I will just open a file explorer here. So as you can see, I've opened a file explorer pop-up. Now one object, consider this as an object, and I've created one object here. Okay, I've got one object. Now I will try to create one more object. Yeah, so here you can see that I'm allowed to create multiple objects or multiple folders of this file explorer. And yeah, this is useful as we can do many things like we can drag and drop folders from directories from our files from one folder to another. So this will be helpful. So it is not implementing singleton design pattern, but in case of task manager, it is implementing a singleton design pattern. As you can see, i'm trying to uh, I'm trying to open the task manager multiple times, but only one instance or one pop-up is displayed here. Okay, now let's quickly uh, jump into the coding part of this singleton design pattern. So let me create a package for this. I'll create as demo. Let's take a package name as demo, and now let's create a class that is singleton. Okay, we'll take an example of this task manager itself. So let me create a class name as task manager. So this is a simple class, and I will just give a constructor, create a constructor for this task manager. It's a default constructor. First we will take example of a simple class, and yeah, for to call this class, or to create an object of this class, let's make let's create one more class. uh, Give this name as task manager caller class. Task manager caller class, as we are going to call this class. And here I will create a main method in which I will create a task manager object. Task manager tm1 equal to new task manager. Okay, so let me create one more object of task manager class tm2 equal to new task manager. Okay, so we have created two task manager objects here. We'll compare those references tm1 tm2. I'll tell you what I am doing here and why I am doing this. Okay, so first, okay, so first what I am doing is here I am trying to compare the references of these two objects. So for object tm1 and tm2, if both the references are same, then we can say that both objects or instances are same. Okay, for now I'll just put both objects are same, and if they are different, then we can say both objects are different. Okay, now so let me just save it, and I'll run it. So as you can see, I'm getting uh, output as both objects are different. So it means that these references are different. So what are these references? Actually, the new object reference is, this reference is a fully classified class name. So if both objects are same, then it would have returned me uh, same fully classified class name. Front. Okay, so this is a normal example, like what I did. I will brief you guys here. So I've taken a simple class as a task manager. Nothing I've done here. Just took this default constructor, and I've created one more class, that is task manager caller class. Here what I'm doing, I've created a main class and creating two objects of this task manager class, as you can see here, tm1 and tm2. So here I'm referring, I'm comparing those references. If you're wondering what I'm comparing with equal to here, so this tm1 will give a fully classified class name, and so these references actually those give us a fully classified class name. So let me just print out quickly what is fully classified class name if you don't know. So tm1 plus tm2. Okay, so let me quickly run it. Here you can see that fully classified class name is this one. So this is a package name, in which package, here you can see that the package in which we have created those classes, and this is a class name for which the object is created, and this is the address, the heap memory, you can say. As you can see that these addresses are different for both the references tm1 and tm2. That's why as we know that these objects are different, that's why the addresses are different. So this if condition is failing because of this, and we are getting the output as both objects are different. So now currently we have not implemented any singleton implementation, singleton pattern. So uh, let me just create. So first of all, before creating singleton, we should know that what is singleton, and how to like how we can create it. Uh, for that, let me brief you some of the things. Like, to create a singleton pattern, we must ensure that only one instance of a singleton class ever exists. Okay, and provide a global access to that instance. Typically, this can be done by declaring the constructor as private, and providing the static method that returns the reference. Okay, let me just create a static method here. Static, I'll return the task manager class, and give the name of this method as get task manager instance. Okay, now yeah, this is giving error as we have specified the return type as task manager and not returning anything. So let me just return null for now. So we are making this constructor as private because we don't want to allow other classes to create object by calling its constructor. So now, as you can see, I have made the classes constructor as private. Here it is throwing error. We will see that afterwards. So for now, first we'll go with uh, eager initialization. That is, we will first create an instance of a task manager. That is, we will declare and define here itself. So first I will go with a final public. Okay, let me make it as static because we are going to return this instance from the static method. Private static final, that is task manager instance equal to new task manager class. Okay, so now as you can see, I have created an instance as a variable and assigned it to a variable, that is instance variable. Now what will I do here? This example is for eager initialization. As you can see, we have initialized it here itself. It means that it is getting initialized at the time of class loading. So that's why it is called eager initialization. And I'll just return this. Instance Okay, let me remove this one. Yeah, so that's it. Now I have to call that method from here. Mm, Let me take task manager class dot get task manager instance. For this also I will take the same task manager dot get task manager instance. Now let's run and check what will be the output. Here, as you can see that this both these references have same object. As you can see the compare object address also they are same. So this is an example of a singleton design initialization. Now let's take an example of lazy initialization. So what is lazy initialization and how it is implemented? Okay, so lazy initialization is nothing but at a runtime we initialize this instance. So not at a class loading time. So we can just remove this and so okay, I'm bring it as null. Initializing it with a null. So I have to remove this final as only if I put a final here, it has to be initialized only once. It will be initialized only once, and this will be its final value. So now at this time in a lazy initialization, we need this final class. As we are not making this one, not making it final, it can be inherited. Okay, so I'm making it final class here. Now, yeah, everything will remain same. Only this get task manager instance implementation will get changed as this. Okay, so what I will do is I will just first check if the instance is null. Okay. If it is null, then I will initialize it with new task manager class. Again, guys, my semicolon button is not working. That's why I have to copy and paste it every time. So yeah, now I have created a new object and I initialized it to this instance. Okay, now I will just return this instance reference. So here what I'm doing is at first time when we call this get task manager instance, uh, as we know that we have initialized it with null, so this condition will get passed and it will initialize this instance with a new task manager. So next time when the same method is called, then this instance will not be null. So this will not initial. So this if condition will fail, and it will just return the instance which is initialized earlier with this new task manager object. Okay, so let me quickly run the same caller class here. Yeah, so as you can see that both the objects are same. We are getting both same objects here. Okay, but there will be one more thing, like if multiple thread comes here, multi-threading. I'm talking about some multi-threading concept here. So then what happens? I mean, if two consider if there are two threads and they are trying to uh, get get this method at the same, they will hit this method at the same time. So at that time, both for both these instances will be at first both for both the threads this instance will be null. So for both the threads, it initializes with a new task manager class, new task manager object. So there will be two different objects, right? So at that time, what is happening here? We are It is breaking the singleton pattern. So for that, what we can do is in the instance, okay, instance if condition, we can just make it as synchronized. We can make use of a synchronized this block. Okay, I will make a video on this multi-threading also. Some concepts like synchronization, what is volatile, all these things. What is atomic integer, atomic long. So synchronized, I will just specify the parameters task manager dot class file. Okay, so now I'm going to put this control. I'll keep it inside only. If it's null, then initialize it, otherwise. Okay, so that's it. And okay, I can just make this variable as volatile. Volatile is a keyword which is used in multi-threading environment where it makes the variable as a thread safe, you can say. I mean, multiple uh, threads cannot access it at the same time or cannot initialize it at the same time. Yeah, so that's it. If hope you guys got this and how the singleton is created and all of this. So yeah, this is somewhat messy, I think, as this is my first video I'm uploading on YouTube. I will definitely improve myself in the future. So please subscribe my channel, Code Main, uh, and yeah, be in touch. Thank you.